So if you've been coding in Python for a bit, you've probably used lists for, well, pretty much everything. But what happens when a simple list just isn't the right tool for the job? Today, we're going to open up the Python toolbox and look at two other essential data containers, tuples and dictionaries. Let's figure out which tool is right for which job.
I just love this quote from Alan Kay, and it's so true, right? In programming, our data is the score, and the data structures we choose, those are our instruments. How we organize that data is absolutely crucial for writing clean, efficient, and honestly just powerful code.
Okay, so think about this for a sec. Lists are fantastic. They're flexible, you can add stuff, remove stuff, change things. But what if you're storing data that shouldn't change? You know, like a set of geographic coordinates or the RGB values for a specific color. The last thing you want is to accidentally modify them. For that, we need a totally different kind of container.
And that, my friends, is where the tuple comes in. The absolute best way to think about a tuple is like a sealed, transparent box. You can see everything inside, you know exactly what order the items are in, but you cannot, under any circumstances, open it up to change what's in there.
So what this really boils down to is one key idea. A tuple is immutable. That's the magic word right there. All it really means is that once you create it, it's locked in. It cannot be changed, period. And making one is actually super easy. You just use parentheses and you separate your items with commas. And just like a list, a tuple can hold all sorts of different data types all mixed together. We've got integers, strings, you name it. Now, here's a quirky little rule you just have to remember. If you're creating a tuple that only has one item in it, you must add a comma at the end. Why? Well, without it, Python just looks at 20 and thinks, oh, that's just the number 20 with some unnecessary parentheses. That tiny comma is what tells Python, hey, this is a tuple. It's a small detail, but believe me, it's a critical one. And this slide just nails the core difference perfectly. On the left, we take a list and we change its second element to 99. No problem, works like a charm. On the right, we try the exact same thing with a tuple, and Python slams on the brakes with a type error. It's basically putting its foot down and saying, nope, you can't do that. This object doesn't support item assignment. That right there is immutability in action. So you might be thinking, okay, why would I give up all that flexibility? Well, it turns out you get two huge wins. First, you get data safety. You can write your code with total confidence, knowing that this specific piece of data will never be changed by accident. And second, you get a little speed boost. Because Python knows the tuple size is fixed, it can make some internal optimizations that often make looping through them a bit faster than a list. All right, cool. So we've solved for data that needs to be set in stone. But let's tackle a totally new problem. What if you're storing something like a student's record? You don't want to have to remember that index 0 is their name, index 1 is their grade, and index 2 is their subject. No way. You just want to look them up by a label, like name or grade.
And for that job, we grab a totally different tool from our toolbox, the dictionary. If a tuple is a sealed box, a dictionary is a file cabinet with perfectly labeled folders. You don't care what order the folders are in, you just want to be able to pull out the right one by its label.
So in Python speak, we call this a collection of key-value pairs. Every single piece of data, that's the value, is tied to a unique label, that's the key. The classic example is a phone book, right? The name is the key, and the phone number is the value. Dictionaries are created with these curly braces. Inside, you define your key-value pairs. So here, the student's name is the key, then you have a colon, and their score is the value. And each one of those pairs is just separated by a comma. And this difference leads to a completely new way of getting to your data. With a tuple, you have to use a numerical index. To get green, you need to know it's at position 1. But with a dictionary, you use the key. You want Ram's score? You just ask for Ram. It's so much more intuitive and readable. And here's the plot twist. Unlike tuples, dictionaries are totally mutable. You can add new key-value pairs, you can change existing values, you can even delete items. Right here, we're just easily adding a new student, Mina, and her score to our dictionary. Simple as that. So now we know how to create and even modify these containers. But how do we actually work with the data that's inside? Let's take a quick look at a few key functions that Python gives us right out of the box. Tuples come with some pretty handy built-in tools. I mean, you can instantly find out its size with len, or you can count how many times an item appears. But check out the sorted function. This one's really clever. Since you can't change the original tuple, it just gives you back a brand new list with all the items sorted. Very, very useful.
Dictionaries give you even more power tools. Need to see just the labels, just the student names? Use .keys. Just want the data, just the scores? Use .values. And if you need to work with both at the same time, .items is your best friend. It gives you everything in these convenient little pairs. These methods make it incredibly easy to loop through your data exactly the way you need to.
Okay, it's time for the final showdown. We've seen tuples, we've seen dictionaries, we know their strengths and their weaknesses. But when do you actually use one over the other? Let's bring it all together. This slide right here, this is your ultimate cheat sheet. It's really simple. If you need a flexible, ordered collection that you plan to modify, you use a list with its square brackets. If you have a fixed, ordered collection that you want to protect from any changes, you go with a tuple with its parentheses. And if you have a set of labeled items you need to look up by name, well, the dictionary, with its curly braces, is your perfect tool. So the next time you're writing code, just stop for a second and ask yourself this. Does this data belong in a sealed box, or does it belong in a labeled cabinet? Getting that choice right, well, that's one of the biggest steps you can take towards writing really clean, efficient, and powerful code.